So to do this, verify the set can be written as this. So this is 4 over 1 plus root 3i. There's a section regards getting rid of the surds on the i's on the bottom. To do that, you must multiply the top and bottom by 1 plus 3i, or 1 minus root 3i, 1 minus root 3i. Basically the conjugate of the bottom. You're going to get a 4 minus 4 root 3 on top, I. This is the difference of two squares, so you're going to get 1 multiplied by 1 is 1. You're going to get plus root 3i, you're going to get minus root 3i, and then at the very end you're going to have root 3i multiplied by minus root 3i. Anybody know what that is?
3i squared.
Minus 3i squared. And minus 3i squared is another way of saying minus 3 times minus 1, which is plus 3. So you can do that in one fell swoop, plus 3. Now all of a sudden you're going to have a 4 minus 4 root 3i all over 4. And the great thing about a question like this is that it's a verify question. You know you walk away with your 5-10 marks straight away. Okay? Now, plot Z on the Argand diagram and write Z in its polar form. First things first, I'll pick up my easy marks. 1 across and how much up? Minus root 3. Yeah. What?
And the Argand diagram. That's 0.5.
Oh yeah, sorry, 1's here. And minus root 3. Now what is root 3 in the calculator? 1.732, right?
Yeah.
1.5, 1.75, just a little bit underneath there. Okay, and that is your Z. Okay, that's easy marks again. A's and B's, you're picking up. You gotta pick them up, okay? Now, polar form. Nothing fancy done yet, okay? Polar, can anybody tell me the equation for polar form? Modulus multiplied by? Now, theta is also known as what's called the argument. Argument means angle. Okay? So, we know that it's in which quadrant? It's in the fourth quadrant, okay? Now, what I can do here is I can do something like this. I'm just going to get this angle here. So what is that angle? It's root 3 here and 1 across. That's angle A. Tan A equals root 3 over 1. Is it 60?
Yeah.
60 degrees. Remember, when we're talking about these angles, we're talking about it in an anti-clockwise direction. What does that make the angle theta? 300. Z equals cos 300 plus I sine 300. Okay? Now, what I got to do next is I got to find out what is the modulus. Please remember that the modulus is actually done by Pythagoras' theorem. So modulus I'll call x. X squared equals 1 squared plus root 3 squared. You all know that that's going to turn into 4 followed by 2. Square root of 4 is 2. Okay, x squared is 4. Now, 2 on the outside, cos 300 plus I sine 300. Now, sorry? Not yet. It hasn't said solve or get all 4 roots. It hasn't said anything like that yet. Okay? Now, this one's actually quite interesting, guys. It says use the Myers theorem. Now, what is the Myers theorem? Just over here.
Or cos n theta.
Okay, if Z equals R cos theta plus I sine theta, and then if we do Z to the power of n, Z to the power of n is Rn cos n theta plus I sine n theta. Question says we want Z10. Z10 is equal to the Z we just got, except this time it's going to be to the power of 10. It doesn't say solve, so I'm not using the rotations. Okay, there's no rotations to be used because it doesn't say solve, okay, or find all the roots. So that means there's no need for what you're talking about, okay? And then what we get is Z10 equals 2 to the power of 10. Is everybody happy with that? R to the power of 10. Multiply your angle by 10. So it's going to be cos 3000. And there's a little bracket there. Plus I sine 3000. Now can somebody tell me what cos 3000 and sine 3000 is?
Minus a half.
Okay, so it's minus a half and
3 over 2.
plus I sine root 3 over 2. Okay, just looking back at the top, it wants us to have a root 3 and it wants us to have a 1. It's a minus, right?
Why is the sign still there?
Sorry. It's minus, isn't it? Root 3 over 2i. Or is it plus root 3 over 2i?
Should not be minus.
It's the first one minus, and the second one is plus. That's perfect. Okay. Now, doing a direct comparison to our answer, right? Now, sometimes it's a very good idea just to do direct comparison to your answer. Direct comparison to our answer looks something like this. The 1 and the root 3 are there, except they change sign. Do you understand that? So, factorise out minus 1. Minus 1 bracket 2 to the power of 10 bracket Frank. 1.5 minus root 3 over 2i. Take it, yeah?
Is there a minus in front of the 2?
There was, but took out minus 1. When I multiply it back in, it fixes it. Minus 1 times a half is minus a half. Minus 1 times minus root 3 over 2 brings it back to plus root 3 over 2. Does everyone understand that this part here by this part here makes this part here? Okay. Now that that's done, what we're going to look at next is I'm going to take out the 2 on the bottom. So it's going to be minus 1 by 2 to the power of 10. I'm going to take out a half, and then I'm going to be left with my 1 over root 3 I. See the way I took out the 2's on the bottom? So if I multiply the half back in, it fixes it. Now, what's 2 to the power of 10 divided by a half? Rule of indices. 2 to the power of 10 divided by 2 to the power of 1? 2 to the power of 9. 2 to the power of 9 multiplied by minus 1? Minus 2 to the power of 9. And there is your 1 minus root 3i. Happy enough? Okay. I'll see if I can do both of them. This one here. Now, put this as a mixed fraction in your calculator. There's a little fancy button for this. Okay, you can see that it's a shift, this button here. Oh wait, I'm still in that mode there. This is 2012. The complex question in there. 5 and 1 sixths. Oh wait, it's more than that. It's 8 and 1 16th, is it?
No, 5 and 1 16.
Okay, 81 over 16. What is significant about those two numbers? They're both squares, and you'll see it come in handy. Now, express in polar form. Z equals R cos theta plus I sine theta. Z therefore equals 81 over 16. That is your modulus. Your argument refers to your angle, 4 pi over 9 plus I sine 4 pi over 9. Now, polar form, 4 complex roots with z's. Okay? Now, I got to expand on this. Where did I do this? It is page 57. Okay? So, W4, I'm just going to write it up here. Rewrite the question. It wants me to find 4 complex roots, so W4 equals Z. We all know that Z is now equal to 81 over 16 cos 4 pi over 9 plus I sine 4 pi over 9. Now Connor, see that language? Find the 4 values. You're talking about your rotations now, okay? So what we're going to do is we're going to modify this now because we know we're talking several different answers. So it's going to be W4 equals 81 over 16 cos 4 pi over 9 plus 2n pi. I'm going to give them the same denominator. I'm going to multiply the top and bottom by 9 here. So that's going to become 18 n pi. Is everybody happy with that?
Yeah.
Top and bottom by 9. Then I'm going to give it a common denominator on the bottom. So it's going to be 4 pi plus 18 n pi. And this one here is going to be sine. There's an I there, isn't there? I sine the same thing. 4 pi. Now, if you're in a test, that's a lot of writing. Okay? So, what you might want to do here, I tend to do this a lot. I come up, once I have this step done, I'll rub that out, and then I'll put the power of a quarter over here. Skip a line in one step. Right? Still get the marks though. Okay? Then I'm going to get everything to the power of a quarter. I'm going to get 81 over 16 to the power of a quarter. Anybody want to tell me what that is? Pretty sure it's 3 over 2. Okay? So it's going to be 3 over 2. And then the next part is, it's going to be cos, multiply that by a quarter. So, this is a difficult one actually.
You just do cos a quarter and then multiply by that.
No, I'm gonna put it as 36, okay, in the bottom. Just want to keep it a bit steady at the moment. Just gonna leave it as 36. Does everybody understand what I did there?
Yeah.
Multiply the quarter by the angle. Okay? And then plus I sine, 4 pi plus 18 n pi all over 36. Now, I have to go through the whole thing of n equals 0, n equals 1, n equals 2, n equals 3. How did I know to stop there? How many answers is there? 4, so I stopped there, right? Plug them all in, okay? Now, what you're going to get is, you're going to get W1 is going to be 3 over 2. Then when you put that in, it's going to be cos, it's just going to be, the n pi cancels. That one disappears. So it's going to be, what is that? 4 pi over 36, which is pi over 9 plus I sine pi over 9. So I want it in polar form still. In polar form. Alright. W, the second one. Call it W1, W2. What is it? 3 over 2 cos, just put 1 for, it's 22 over 36, isn't it? Which is the same thing as 11 over 18. That's when n equals 1. Are you guys okay to finish that off now? Just put in n equals 2 and then n equals 3. Okay, what I ask you to do next is set is marked on the Argand diagram below. That's our first one, which is this one here. On the same diagram, show that the 4 answers to part A. So it wants me to draw this out. I got to go to my calculator, and this is really painstaking. You got to go to your calculator, and what you're going to do is you're going to put in your you got to make sure you're in radians for a start. Shift mode setup, go to radians, which is number 4, and you got to do it this way. Cos, you got to do 3 over 2. See your modulus, yeah. 3 over 2. Oh dear. 3 over 2, and then you're going to press cos. What's that? 11 pi over 18. Okay. Equals, and then you got to take that down. Minus 0.51. That's 1 point, and then you got to go back up again, and then you got to float over here, and then you got to delete that, and you got to do the sign, and now you know that's 1.41. You got to do that 2 more times. You have to do it for W3 and W4. Now it turns out the next one turns out to be there's one that's minus 1.41, and what's the other one? Minus 0.51. And what's the other one I'm missing then? I'm missing that one. There is the first one. The second one is minus 0.5, and then 1.41 is around there. The other one I'm missing is minus 1.41. There it is there. Then minus 0.5, which is here. And then if you draw a straight line, and then I forgot the very first one, didn't I? The pi over 9. I forgot n0. N0 is, if you do the same thing again, n0 is 0.51, 1.41, which will take me, 0.51 is there, 1.41 is, oh wait a second, opposite way around, excuse me. N0 is the opposite way around. So we'll do N0 now actually, okay? So anybody has to go, you can go. Anybody wants to stay, you can stay. Okay, so what we're going to get is cos 3 over 2 pi over 9, yeah? 3 over 2. 3 over 2 cos pi over 9, which is the original one. Shift pi divided by 9. That is 1.41, okay? So that's plus 1.41. And then the other one is going to be plus 1.41, and then we have to go up again, and then we have to find out what sine is. So each one of these solutions can be represented as a point on the Argand diagram, 0.51. So does everybody understand W1, W2, W3, W4? They can be represented by a point, where the point is the x value is the cos value, and the y value is the sine value.
So I need 4 points.
I do, I'm working on it. So this one here is 1.41, up 0.5, which is there. And you can see it's making a bit of a square, isn't it?
Circle, I think.
Sorry?
It's trying to be a circle.
Just give me a second with it. Okay, and then the last point, we'll write down the other two now while we're here. I'll write down W3 and W4. W3 would have been, what was it? It turned out to be cos 3 over 2, cos 10 pi over 9, plus I sine 10 pi over 9. See the way it was over 36 originally? When you put in n equals, what's it, n equals 2, is it? It'll be 40 over 36, which is 10 over 9. Okay? And then W4 is 3 over 2 cos 29 pi over 18, plus I sine 29 pi over 18. Okay, can somebody check what cos 29 pi over 18 is? I think that's the only one I'm missing. Cos 29 pi over 18, anybody? 3 over 2, 29 pi. I'll do the sine value if you do the cos value. Sine value is minus 1.41. And I'm assuming your value is 0.51. Yeah, there's the last one. So 0.51 is a half, and it goes down minus 1.41. Now, what you can see is that this, if I link them to the centre of the circle, that's W1. That's the very first one. It then rotates 90 degrees to become W2. W2 then rotates 90 degrees to become W3. W3 rotates 90 degrees to become W4. And there's your rotation. And I think what you said comes true, that it actually will be a circle.
Should it be a circle of radius 3 over 2?
Yeah, exactly. A circle of radius 3 over 2. Is that alright?
So could you change those to degrees when you were filling in all